So 8, 2, and 3 are going to be combined here, and they both deal with how to prove that triangles are similar, and then if they are similar, how their parts relate to each other. So the first thing is that you don't need all 6 corresponding parts of triangles in order to show that they're similar. So you don't need to show that all 3 pairs of angles are equal and all 3 pairs of sides are proportional. There's 3 patterns that you need to be familiar with. The first is the AA similarity pattern, which is abbreviated AA similarity. And so if this is the case, all you need to do is see that 2 pairs of corresponding angles are equal. If that's the case, then you know that the triangles are similar. So 2 triangles are similar if they have 2 pair of angles that are congruent. Okay? And so if you just see these 2 pairs of angles congruent, then you know that triangle ABC is similar to A has the 1 tick mark corresponding to point D, B has the 2 tick marks corresponding to vertex E, and then C and F have no tick marks, and those will correspond. So by AA similarity, those are similar triangles. Once you have that they're similar triangles, then we use the properties of similar polygons. All corresponding angles are equal, and all corresponding sides are proportional. So if you're looking at these types of problems where this will come into play, okay, so what you see right here is, if we take this first example, we're given that these 2 angles are equal. And you also know that this pair of corresponding angle, or these pair of vertical angles right here, are also equal. And so by AA similarity, you know these are 2 similar triangles. And so if you know that triangle ABC is similar to triangle, again, A is the 1 tick mark, that corresponds with E. C is the 2, or B is the no tick marks, that corresponds with D. And then C and C are the same angle with 2 tick marks. So these are your similar triangles. And so if you want to find the side X, so the side X corresponds to, X is AC in the larger triangle, so that's going to correspond to EC. So if we find the length for EC, which is 20, you know that X over 20 is equal to the known ratio. Well, you have both of the remaining sides in the large triangle, but all you have is side DE of the smaller triangle. So again, DE is the first 2 letters, so A and B are what that corresponds to. So A to B is this length of 63, is to ED, which again was 45. And so this gives you your ratios. Set them equal and solve. And so here, if we solve for X, multiply both sides by 20, and we get our calculated value here of 63 over 45 times 20, and that gives you your answer of 28. You could have entered your answer as a calculation as well, okay, but either of those forms would be acceptable. All right, second example here, you see that these lines are parallel. Okay, which means that corresponding angles are equal, right? So this angle and this angle are equal, these 2 angles are equal, and so right there you have your AA similarity. You could have also thought of it as just one of those pairs of angles, and then both of these triangles also share this common angle down here. So once again, you would have AA similarity by having 2 pair of angles that are equal. Either way, once you find this out, what you can do is you can solve for your corresponding parts. Notice these triangles are oriented in the same direction, so even though there's no points to label, we see that X corresponds to this corresponding length 36 in the same ratio that we have this whole side of the large triangle, which is 35, over its corresponding piece in the smaller triangle, which is 20. And so once again, if we multiply both sides by 36, we can solve for our X value. You can either enter this whole calculation, or once again, if you write 35 over 20 times 36, you would get your answer to be 63 for that value. And the final question here, once again, you're told that YP and ZS are parallel, so similar to the previous question. And so if that's the case, you have these corresponding angles that are equal plus the shared angle. So by AA similarity, you're dealing with similar triangles. And so once again, if you start to label what you have, YP is 30, ZS is 23, and ZQ is 13. And so what you want to do is you want to find this YQ value. So a couple different ways that, or the way that you can think about what that is. We'll just call that our unknown, which I'll call X. And so if we take our corresponding piece, X is 2, so again, here's X. X corresponds to this smaller portion, 13, of the smaller triangle. And then we have our known ratios, which are these two sides here. So that's 30 is to 23. So that is the proportion that we set up. Multiply both sides by 13. So once again, you could enter your calculation as it is, or you can perform the calculation and enter the calculated value. If you do that, you get approximately 16.96. But again, you could have entered this full calculation as well. 2 was just the AA similarity. 8.3 is going to introduce the remaining two similarity patterns for triangles, and that is SSS and SAS. So the SSS similarity pattern is that if all three sides of two triangles are proportional, then the triangles themselves are similar. Okay, so two triangles are similar if all three pair of sides have the same ratio or are proportional. Okay, so if we are looking at, let's say, X, Y, and Z here for the sides of this triangle, if this is n times some multiplier n times x, that same multiplier times y, and that same multiplier times z, then you know that these have to be similar triangles. So ABC is similar to, again, A is opposite the Z, just with a dilation factor of n, so that corresponds to R. B corresponds to S, and C corresponds to T by using proportional sides, so SSS similarity. And SAS similarity is, again, the same idea, combining the two. So you have two pair of sides that are proportional and the included angle is equal. And if that's the case, then the two triangles are similar to each other. So two triangles are similar if two pair of sides are proportional and the included angle are congruent to each other. So again, that's the two S's and the A. So here we have this pair of angles that are equal. So if we know that one side, let's say, is a length A, and for the corresponding triangle, it's M times A, and then the other side is B, and in the other triangle, it's M times B to get the larger side, then you know that these are two similar triangles. So again, triangle XYC is similar to X corresponds to M, Y corresponds to N, and P corresponds to Z. And that would be by the SAS similarity pattern. Two pair of sides are proportional and the included angles are equal. So we're going to use, we're going to view all three patterns here, looking for all three patterns to see if these triangles are similar. Okay. So here we want to find what value of X would make these similar, which would be that You can see, again, look at how the statement's written. A corresponds to D, B corresponds to E, and C corresponds to F. Notice these are all already arranged in the same orientation, so visually we're good. We can just relate to the corresponding pieces. And so if we take one of the lengths with X, and again it can be either one, I'll tend to start with the larger one if I can. So 7 times X minus 4, that side length corresponds to this side of 13 in the other triangle. And in order for that to be true, then the corresponding ratios would have to be the same. And you can compare it to either other ratio. Okay? So the fact that 6 and 42, this is an easier comparison. The triangle with the 7 times x minus 4 has the side of 42 to the other triangle's 6. And so here, if we multiply both sides by 13 and simplify, 6 goes into 42 7 times, divide by 7, the 7's cancel, add 4 to both sides, and so you see that x is equal to 13 plus 4, or 17. Now, you could have used either of these, so this isn't the only form that you could have solved. We could have solved this side first, so we could have taken x minus 8 over its corresponding piece, 63, set that equal to, again, the same ratio. 6 is the side of the triangle, or the side in the same triangle as x minus 8, so that goes on top, and that corresponds to 42. And so if we multiply both sides by 63 here, we get x minus 8 is equal to 6 goes into 42 7 times, 7 goes into 63 9. Add 8 to both sides, and we would get x is equal to 17 using that pair of that pair of sides as well. Okay, if we come up here, okay, if you're given that BIG is similar to MOP and you want to find what y is equal to, and you can set up your similar triangles here. You just need to figure out which ones are oriented. So I'm going to redraw my smaller triangle in the same orientation. So M corresponds to B, so B is going to go here. O corresponds to I, so I is going to go down here, which leaves G. And if I take their side length, so IG is 200, label that. BG is 216, so label that. And what I now have is this opportunity to set up my ratios. So Y is to 200 as our known ratios. 1404 is to 216. And so it's just a matter of solving. Once again, I can enter my answer just as this calculation. Okay, but if I type that in, I get my length of x, the length of y to be 1300. And so that would be my answer. Final one, same idea. You're told that these are similar triangles, so I can label it the same way. I'm going to orient my figures in the same direction once again. So M and B correspond, so B labeled up here once again, O and I, and then G and P. So here's my figure. I'll mark what I have. So BG is 48, IG is 42, and BI is my length V. And so this is what I'm solving for here. So I'm going to take my length V corresponds to 24 in the same ratio as I have my longest side here. So 48 is to 72. And if I simplify, or if I isolate and solve for V, I get my calculation 48 over 72 times 24, and that leaves me with 16. And once again, I could have entered my answer as this calculation, or the calculated value. The last type of questions that I want to look at here are the type of questions that you would likely see on. Right. So the last type of questions is, again, just putting everything together. The type of questions that you can expect to see similar triangles being used to solve. So first, from a story problem standpoint, if you have objects casting shadows, the assumption is that if you have a flagpole that's casting a shadow and a tree nearby that's casting a shadow, what you're assuming is that the sun is coming from this same angle. This is called the angle of elevation from here to here. And so that's going to be the same. It doesn't matter what it is, since the angle up to the sun is the same for both of these. So you have this right angle and you have the angle of elevation. That gives you two angles, meaning these are similar triangles. And so if you know that the flagpole casts a 17-foot shadow, a nearby tree casts a 39-foot shadow, and you know that the tree stands 15 feet tall, what you can do is you can find the length of this, or the height of this unknown flagpole, by setting up and relating these corresponding parts. So side H corresponds to 15 in the same ratio as 17 corresponds to this shadow length, 39. And so if you just calculate your answer, you get your solution here, which would be 17 over 39 times 15. And so the height of that pole is going to be 6.54 approximately. Or you can leave it as this calculation. So either of those would be acceptable answers. In the next problem, once again, you're finding all the corresponding parts to this. I would again redraw my figures so that they're facing the same orientation. So M and B correspond, so M means B is going to be up here, O and I, so I'll write I here and G here. And if I relabel what I have, so BI is V, IG is 56, BG is 64, I have this angle G is 32, and the angle O down here. I can go ahead and kind of relate these corresponding pieces. So if I look at just these triangles, what I do, what I can see is that this angle X is going to be formed by taking the triangle sum. So X is 180 minus the two given angles, 110 and 32. And so if I calculate that, 180 minus 110 and 32, that's going to leave a measure of 38 degrees. Again, you could leave your answer as a calculation if you wanted to as well. Okay, and then the other pieces are the side lengths. And so if I look for V, V corresponds to 24 in the same known ratio. Well, the only known ratio I have are these two longest sides. So in V, the corresponding side is 64, and in the other triangle, 96. And so once again, I can leave my answer as a calculation here, or I can calculate 64 over 96 times 24. So that leaves V is 16, or the calculation. If we look at W, W is this measure, which I already established was 110 by using the corresponding parts. If two similar triangles, the corresponding angles are equal, so W would be 110 degrees, same, And then finally y. Y is this length. Y corresponds to 56 in the same ratio as our known value. So here, since we started with y, we'll use 96 over its corresponding length, 64. So if we solve both of these, multiply both sides by 56, you can either leave your calculation, or if you take 96 divided by 64 and multiply that by 56, you'll get your answer for y, which again is 84, or the calculation here. All right, the final problem down here. Again, you want to find what value of x is going to make these two triangles similar. And so when you are looking at these measures, you need to be able to see x is this DC. So DC are the first and last. So that's going to correspond to A and C. So being able to match up what your corresponding pieces are, x over 32 is equal to the known ratios. Well, even though we're only given two other side lengths, let's verify that they are the corresponding pieces as well. So E and C are the last two letters. Does that correspond to B and C, the last two letters? Yes, it does. And so if we take the triangle from, or the measure from the smaller triangle, since we started with x, we start with 11 over its corresponding measure, 23. And then it's just a matter of calculating. And so you can enter your answer as the calculation 11 over 23 times 32, which gives you 15.30. Or you can leave it as this calculation, and that would be your solution.